Limit as x goes to 0 sine x over x. What I want to do is graph it, and I want to look at a table with values 0.1, etc. So I set up a table there. Let's take out the graphing calculator. If to get this screen, you would come over here to second window, which is our table set. We don't really care what this value is. We can have it at anything. It really doesn't matter. What we want to do is make the independent variable to ask. Then when you go to table, you can type in any value you want. So I can delete these, for example, and I can type in negative 0.001. Now it says that these values are 1. Let's take a look and highlight them. Is it really 1? No, it's 0.9999998, which is pretty close. Let's take a look at another one, 0.0001, and see how close that has even more 9s. So we can write that down. We have 0.998, 0.998. We have 0.9999. I think there were 6 9s. And then we just had a bunch more 9s. And the same thing over here. Do you notice that both sides are the same? Why is that? Because it's an even function. How do we prove it's an even function? We can plug in negative x, and we get sine of negative x over negative x, and that will simplify to just sine of x over x. This graph looks like this. Comes in. That value is 1. Now, this is not a proof. This is looking at specific numbers, a graph, and it seems to be 1. It turns out it is 1, and we can prove it. It requires a little bit more knowledge than we have right at this moment, but we'll get to that soon. Well, if this sine x over x, in other words, the ratio of sine x over x is going to 1 as x goes to 0, what do you think the ratio of x over sine x is going to go to? That will also be 1. Let's look at the rest of these. When you see something like this, you want to think algebra. Just in all these limits, if you don't see what to do right away, think algebra. What can I do algebraically to this? I can split it up to x over x plus sine over x. Now what is x over x? That's 1 for all values except 0. Do we care what happens at 0? No, because the limit of the function never depends on the value of the function at that point. So this just gives us 1 plus 1, which is 2. Now we come over here, and this says the limit as x goes to 0, sine 3x over sine 2x. This is a great one to play around with and see if you can figure it out. I'd strongly recommend hitting pause. Recall that we have the limit as x goes to 0, sine x over x. Another way I could write it is limit as theta goes to 0 of sine of theta over theta equals 1. Or I could write it as the limit as box goes to 0 of sine of box over box. And what I'm trying to emphasize there, as long as the inside of the sign, the argument of the sign, is the same as what is dividing by, and that is going to go to 0, then that ratio goes to 1. So we want to try to create that in this problem. We can say limit as x goes to 0 of, well, we definitely don't have that now, but what if we split this up to something like this? Now can you create it? I have sine 3x. What do I want on the bottom? I want a 3x. Now I just changed this problem, so I have to counteract that 3 and the 4 by multiply. Since I'm dividing by 3x, I'm going to have to multiply by 3x. So I'll put a 3 out in front, and I'll put an x over here, because I'm going to need the x for the sine 2x. What do I want on the top of this one? in order to get the exact same thing as what this is a sine of. I want a 2. Well, again, I just changed the problem. I can multiply by 1, but 2 over 2 is 1. Now I can say 3x times 1 times 1, or 3 over 2, sorry, I think I said 3x. 3 over 2 times 1 times 1, and we get 3 halves. Let's take a look at a couple examples with the greatest integer function. If we're going to go to 2 from the left side, we can look at this with a table. What kind of numbers are we going to come at 2 from the left side? 1.9, 1.99, 1.999. What is the greatest integer of 1.9? It's the greatest number less than or equal to that value, so it is 1. 1.99, 1. 1.999, 1. As many 9s as you want as long as you stop. 1. Similarly, if we come over here and say 2.1, 2.01, 2.001, it will be 2, 2, 2. So what is the limit as x goes to 2 of the greatest integer function? Does not exist. Why doesn't it exist? Because these two from both sides have to go to the same thing. Now, what's special about this? Can't we just plug it in? Because if you plugged it in, you will get a number, but there's a jump that's happening at that 2. So we need to look and see what's happening on both sides.